Welcome to section 8.1, the square root property and completing the square. Alright, so first off, we have the quadratic equation, and we have worked with these before, but what is the quadratic equation? So the basic definition of it is ax squared plus bx plus c equals 0. So the main thing that you want to notice about a quadratic equation is we have an x to the second power, and that's the highest one that we have. So far, what we know how to do with this is we know how to do the zero factor property. But sometimes that doesn't work. So let's take a look at some other methods. But first off, example 1, which of the following are quadratic equations? So take a second and see if you can determine which one's quadratic. Well, the first one, you might be tempted to say it is because there's a square there. But remember, for it to be quadratic, the highest one needs to be the square. And a cube exists, so this is not quadratic. In the second one, we do see a square, and the square is the highest one, so we know that this is quadratic. In the last one, do we see a square at all? We don't. The highest power is a 1, so this one is actually linear. So this is not a quadratic either. So we have one quadratic, and it's very important to know how to identify quadratic equations and linear equations and so on. So definitely practice that if that's something that you're still working on. So first off, a reminder on the zero factor property. So if we have two numbers that have a product of 0, then one of them must be 0. This is just a quick overview on it. Remember, you can go back into the other sections and how we did this. So if we have a times b equals 0, then either a equals 0 or b equals 0. So let's go ahead and solve example 2 for x using the zero factor property. First off, you'll notice, is this equal to 0? It's not, so we need to go ahead and set it equal to 0 to do the property. So add 4 to both sides. And one thing to note, I did notice this last time I was grading, some students were putting some equal signs on the side. And that's not needed. Why? Because we have an equation, so we already have our equal signs in the middle. So the only times you have the equal signs on the side are if you're using an expression. Okay, so since we're with equations, we'll go ahead and we won't use those. Alright, so let's keep solving. So the zero factor property is to set it equal to 0 and then factor. And I can factor this by doing x plus 2 and x plus 2 equals 0. And then I'll go ahead and set each factor separately equal to 0 and solve. And in this case, we actually get the same answer both times. It doesn't always happen that way, but it happened with this one. So x equals -2. Alrighty, and we're done. So that was the zero factor property. But the main ones we're going to look at for this section are the square root property and completing the square. So the square root property. Once again, you can read through these a little more in detail in your book, but if x and k are complex numbers, and x squared equals k, then what can we do? Then if we have x squared equals k, we can go ahead and we can take the square root of both sides. And when we do that, we need to do a plus or a minus. So we get that x equals plus or minus the square root of k. Where does this come from? Well, if you think about it, if I told you some number times itself equals 4, right? Because if we had some number squared, which means it's times itself equal to 4, what would that number be? Well, there are two options. We can do -2 times -2 equals 4, or +2 times +2 equals 4. Which is why we need that plus or minus, because there's two possible options. Alright, let's go ahead and use the square root property on the following. So example 2, solve using the square root property. Well, if you'll notice, with the square root property, we want the squared item by itself equal to the other items. And for the first problem we have here, the squared item is not by itself. There are two things keeping it from by itself. That 3 and that -52. So let's go ahead and get it by itself by first adding 52 to both sides. So we get 3x squared equals 52. And then let's divide both sides by 3. X squared equals 52 divided by 3. Okay, so now it's perfectly set up for the square root property, so let's go ahead and do that. So we have the square root property, and then very important, once again, the plus or minus. That is something that I do look for in the grading, so make sure to have that plus or minus. Okay, so that cancels there, and we're left with x equals plus or minus the square root of 52 over 3. We're not done yet, though. We need to simplify that radical. Well, 52 and 3 don't simplify together, so because they can't simplify together, I'm going to go ahead and split them up. And then 52 is 4 times 13. So go ahead and rewrite it as root 4 times root 13 divided by root 3. Let me fix this up a little. Okay, so we can simplify the 4, but then the next problem we have is we have that root 3 in the bottom. We cannot have radicals in the denominator. So how do we get rid of that? Well, we're going to go ahead and multiply it by root 3. And then we have to multiply the top because it's the building up property. But why did I multiply it by root 3? Well, that's because, oops, sorry, that's going to be 3 root 39 divided by, when we have 3 times root 3, we'll get root 3 squared. And that would cancel and just give me the 3. So I'm left with 3 in the denominator, and I'm done. Okay. So it almost seemed like the harder part there was the simplifying than the actual solving. So let's take a look at the next example. Now this one's weird because I don't have like just my variables squared. Where is the square? The square is over this entire binomial. The same sort of concept applies. We want to have the squared item by itself. So what is keeping the squared item from being by itself? Well, it's that 1 right there. So let's go ahead and subtract 1 from both sides to get our squared item by itself. Alright, so now let's go ahead and solve. And to do that, we'll just go ahead and square root both sides. Once again, remember, you do need to write the plus or minus. Definitely important. Okay, then the squares cancel each other out, and we're left with 3y minus 4 equals plus or minus root 4. So simplifying, what do we get? Plus or minus 2. Well, this looks pretty much linear, because we just have y to the first power. So let's go ahead and keep solving. Add 4 to both sides, and this is where it's kind of weird. You want to write the new number in front of the plus or minus. Okay, so definitely keep that in mind. 3y equals our number, and then the plus or minus. And only one thing left to do. We got to divide both sides by 3. And we have y equals 4 plus or minus root 2 divided by 3. We're super close to being done. However, we have 2 possible answers, the positive version and the negative. So we have to go ahead and split this. We can do 4 plus 2 over 3. And then we have the option of y equals 4 minus 2 over 3. So that'll give me 6 over 3, which is going to be 2. And then that'll give me positive 2 over 3. Alrighty. And there we go. We have our 2 answers in that one and our 1 in the other. Or sorry, it is still 2 in the other because they're both plus or minus. Okay, let's take a look at completing the square. That box is kind of off. Okay, so what are the rules for completing the square? Well, basically it comes from wanting to get our equations to look like this form right here. Like this one, which was 3y minus 4 squared equals a number. We want to get it something squared, because then we can just use the square root property instead of trying to zero factor like we would do before. So in completing the square, if we have something like ax squared plus bx plus c equals 0, what we're going to do is first move the constant to the other side. That's the first step. Then what we're going to do is make sure that there is no number in the front by the x squared. So divide everything by that constant. So 1, 2. Okay, so then we would have x squared plus b over ax equals 0. Then the third thing we're going to do is we're going to take the middle value, b over a, we're going to half it and then square it. Kind of weird, but that is the plan. And there is a way to show how this is proved, but we're not going to work on that now. If you'd like to figure that out, please send me an email and I can show you how that works. And then the value we get there, that is going to equal 2b over a squared. And we'll add that into our problem. So we have x squared, and then we have the new number we created. And that number, whatever it looks like, we'll add that into our equation to both sides. And that will allow us to perfectly complete the square. And rewrite our number as our x plus our number squared equals to a number. And then lastly, we'll go ahead and use the square root property. Okay, so this is very basic definition or a way to complete the square. Once again, if you want to see this in more detail, where it's written out in words, that would be on page 536 of your textbook. Okay, so let's go ahead and practice solving by completing the square. So for this, is it quadratic? It is. We have the square, so we know it's quadratic. So then the next thing is, how do I complete the square? First off, we want to make sure to move the coefficient or the number to the other side. So let's go ahead and do that. So we can add 3 to both sides. And we get x squared plus x equals 3. Now we need to make sure the item with the x squared does not have a number in front of it. And it doesn't, it's just a 1, so we're good. So for completing the square, we'll take the value by the b, which in this case is just a 1. We'll half it, and then we'll square it. So that's going to end up equaling a 4th. Now why do we care about this number? This number, when I add it to my equation, will allow me to factor into perfect binomials. So let's go ahead and add that in. So x squared plus x, and then we're adding in our perfect number we found, 1/4. And once again, we have to add it to both sides because we're in an equation. So we get x squared plus x plus a 4th equals, well, 3 and a 4th. So now, why did I care about that number? Well, because I can factor my x, or my quadratic here, into x plus a half times x plus a half. It's a perfect binomial. Which, since they are exactly the same, what can we do with them if they're exactly the same? We can rewrite it as x plus a half squared. And then that equals my number, so let me go ahead and change this into a mixed number. So 3 times 4 plus 1, so that's going to be 12, 13 over 4. Okay, so now it's set up in the perfect format. Once again, we did all of that work, finding that specific number, adding in the number, and then factoring it, so we could rewrite it as the perfect squared. So now let's go ahead and take advantage of that. Square root both sides. Remember your plus or minus. The square cancels, and we're left with x plus a half equals plus or minus the square root of 13 over, and I'll simplify that root 4 into 2. Then we can subtract a half from both sides, and we get x equals 1 plus or minus root 13 over 2. All right. It definitely is a bit of work, but it's really nice because once we find that perfect number that we can add to our equation, then we can easily factor it, and then we get the nice square root property in the end. So it's kind of fun when you can do that. All right, let's take a look at the last one for this problem. Completing the square. First things first, we got to move that number to the other side, so let's add 5 to both sides. And then we have 3x squared plus 12x equals 5. Can we take the middle and take the half yet? Not yet. Why not? Because we need to have the x squared by itself, so let's go ahead and divide everything by 3 first. Now x squared is by itself, that's what we needed. And I'm going to leave space for that perfect number we're trying to find. So now, let's go ahead and find the number that will make my trinomial here into beautiful factoring. How do I find that? Well, I'll take that b value, divide it by 2, and then square it. So 4 divided by 2 is going to be 2, and then 2 squared is going to be 4. So 4 is my perfect number, so let's go ahead and add 4 to both sides. Why is 4 perfect? Well, when I add 4 to this trinomial, it factors perfectly into identical factors, x plus 2 and x plus 2. So 5 over 3 plus, let's go ahead and build that up, 12 over 3. So now I can rewrite these guys in the form that I want. This is why I'm doing all of this. I can rewrite it as x plus 2 squared. And that'll equal, so 12 plus 5 is going to be 17 over 3. So now it's in the perfect format, so let's go ahead and use the square root property, which again is why we did the completing the square. Plus or minus, those cancel, and we have x plus 2 equals plus or minus the square root of, and I'm going to go ahead and just rationalize this in my head right here. Square root of 17 times the square root of 3 over 3. So once again, I rationalized the 3. Subtracting 2 from both sides, we get x equals negative 2 plus or minus the square root of, and 17 times 3, that's going to be 21, 51. Square root of 51 divided by 3. Okay, so skipped a few steps there. Once again, if you have any questions on the lectures, drop by my office hours or send me an email. I'll be glad to work with you on anything. Once again, communication is important, so make sure to reach out to me if you need help with anything like the lecture notes or the My Math Lab. Other than that, that is it for this section. Once again, please reach out if you need help.